Question 5. This question about the chemical properties of chlorine, sodium chloride, and sodium bromide. Sodium bromide reacts with concentrated sulfuric acid in a different way from sodium chloride. Write an equation for this reaction of sodium bromide and explain why bromide ions react differently from chloride ions. The equation part, how well do you know your equations? So sodium bromide, NaBr, plus this concentrated sulfuric acid, H2SO4, and we've got a 2 here, a 2 here, and then we form Na2SO4 plus Br2 plus SO2 plus 2 AH2O. 2 NaBr plus 2 H2SO4, Na2SO4 plus Br2 plus SO2 plus 2 H2O. The explanation: chloride ions and bromide ions. Well, Br minus ions are much bigger than Cl minus ions. Hence, Br minus ions are much more easily oxidized, aka they can lose an electron more easily than Cl minus ions. Because they're much bigger, it's easier for them to lose an electron because of the weaker attraction. 5.2. Color solution contains a mixture of sodium chloride and sodium bromide. Using aqueous silver nitrate and any other reagents of your choice, develop a procedure to prepare a pure sample of silver bromide from this mixture. Okay, so we're going to have 3 stages. It's a 6 marker. Stage 1, formation of precipitates. We want to add silver nitrate to form precipitates. Well, if we add silver nitrate, what we're going to form precipitates of to chloride and bromide ions, we're going to form precipitates of AgCl and AgBr. Sodium chloride and sodium bromide reacting with AgNO3. Well, that's what we're going to form, AgCl and AgBr. So equations: AgNO3, first you need to know what the formula is of silver nitrate, and if you don't know it, well, you clearly haven't studied your equations well enough. I only learned it like maybe last month, a couple of weeks ago, so yeah, it's pretty important, but not the end of the world. So plus NaNO3 and then AgNO3 plus NaBr, sodium bromide, to form AgBr plus NaNO3. Show the formation of the precipitates. Stage 2. Stage 2, selective dissolving of AgCl. We want to add an excess of dilute ammonia to mixture of precipitates, and what will happen is that the silver chloride precipitate dissolves, and the equation, well, AgCl, adding dilute ammonia, add NH3, and what's going to happen is we're going to form NH3 2 plus Cl minus chloride ion. I'm also going to have a 2 here. So AgCl plus 2 NH3 arrow, AgNH3 2 plus Cl minus. And then stage 3. Stage 3, separation and purification of AgBr, silver bromide. So we want to filter off remaining silver bromide precipitates. We want to wash to remove, why do we wash it? To remove soluble compounds. and then we want to dry to remove water. So stage 3, separation and purification of silver bromide, AgBr. Filter off remaining silver bromide precipitates, wash to remove soluble compounds, and dry to remove the water. And then 5.3, run a nuclear creation reaction between chlorine and cold dilute sodium hydroxide. So Cl2 sodium hydroxide. Sodium hydroxide. Ionic equation, so plus 2HO arrow OCl minus plus Cl minus plus H2O. Cl2 plus 2HO arrow OCl minus plus Cl minus plus H2O. And oxidation state of chlorine in each of the chlorine containing ions. Well, in OCl minus, the oxidation state of chlorine, well, oxygen minus 2, overall minus 1, so chlorine is plus 1. And what else do we have for chlorine? Chlorine ions. So in Cl minus, the oxidation state is minus 1, obviously. And that is the end of question 5.